Okay, I hope my screen is visible to you. Is it?
Yes, sir.
Alright. So I'm just giving a few terms to you. Just write down very quickly. The first term is annual rainfall. Annual rainfall. You all know the term, right? That is the collection of a rainfall in a 365-day period of time, right? So write down the amount of rainfall collected. You may please write down in short the amount of rainfall collected by a given rain gauge in 24 hours is called the daily rainfall, and the amount collected for 1 year period of time is called annual rainfall. Okay, give the next term average annual rainfall or normal annual rainfall. Average annual rainfall or normal annual rainfall. This I have already explained to you earlier. So what is normal annual rainfall? The annual rainfall at a particular station when recorded for a long period of time, like 35 years, 40 years of time, and then whenever we averageize this annual rainfall, we get this average annual rainfall over that entire period, right? So write down this is the average value. This is the average value of various annual rainfalls at a particular station recorded over 35 to 40 years period of time. 35 to 40 years period of time. Right? Then there comes a term which we call as index of wetness. But can someone tell where have we used this term of normal annual rainfall before? कहाँ पे use किया था? Can someone tell?
Estimating the missing rainfall data.
Yes, estimation of missing rainfall data. There we have already used this term, right? So similarly, there is another term called as index of wetness. So what this term tells? This actually tells about how much a particular catchment has been wetted as compared to the normal annual rainfall, right? So if we say that in general some catchment receives 100 centimeter of a rainfall in a year, and this year it has received like 70 centimeter, so we'll say that the index of wetness is 70%, correct? So it's generally a criteria to determine whether there is a sufficient rainfall over a catchment or a basin or not, right? So in general, if we have got somewhere more than 85 to 90%, we call it normal rainfall. Okay, if it is more than 85 to 90%, below this value, we call it less than normal, or we can also say that there are drought conditions. ठीक है, कहते हैं ना सूखा पड़ गया इस साल, तो वो यहीं से कैलकुलेट होता है. ठीक है, कि डिफिशियंसी ऑफ रेन अगर ज्यादा है तो वी कॉल इट ड्रॉट, एंड इनवर्सली आल्सो इफ इट इज मोर देन 110% और सो देयर विल सर्टेनली बी फ्लड कंडीशंस. उसके लिए कैलकुलेशन की भी जरूरत नहीं पड़ेगी, ऑलरेडी फ्लड आ जाएगा. ठीक है, so you can write down this index of wetness in the form of a ratio, that it is an actual rainfall in a given year divided by the normal annual rainfall of that place. Okay, so these were some of the minor terms you should know. कभी कभार competitions में भी आ जाते हैं, so you should have a fair idea of that thing, right? Now just write down, give a heading, estimation of the mean rainfall. This is very important topic, one of the important topics. Okay, so there are various methods to actually estimate this mean rainfall value, right? Like you can also have a simple average of all the rainfall value. Abhi mean rainfall kya hai? Actually it's not about a particular station, it's about a entire catchment area, right? You have number of rain gauges installed at various places in a catchment. Okay, these are called rainfall stations or the rain gauge stations. You all know that, right? Whatever rainfall value we get from that particular station, we call this thing as point rainfall. Point rainfall or station rainfall. Generally we use this term point rainfall for representing a particular rainfall value at a particular station, right? So we have a number of rain gauge stations like that. Now whenever we represent a particular catchment area, and if we have to denote some particular rainfall value to it, we just cannot give all the rainfall values of all the stations, right? अगर किसी catchment में suppose कीजिए 50 rain gauge stations हैं, तो मैं पूरी 50 values किसी को बताने नहीं जाऊंगा, मैं एक particular value बताऊंगा which will be an averaged mean of all those rain gauge values or all the precipitation values of all the stations, right? So we have to determine that particular mean rainfall data. ठीक है, अब आप जैसे कहते हैं कि ठीक है मेरे टाउन में इतना रेनफॉल हुआ, इतना रेनफॉल होता है साल में, या पिछले साल इतनी रेनफॉल हुई, right? So that particular rainfall, whether it is 100, 120, 80 centimeter, 150 centimeter, that is an averaged value taken from all the rain gauge stations, right? So it is important to determine this parameter of the mean rainfall. Now there are various methods and it depends how your catchment or the topography of the catchment is like. Now if we can say that there is a fair distribution of the rainfall over the entire catchment, so you will see that the variation of the rainfall will come down, right? If this is receiving 100, this might receive 95, this might receive 90, 92, like that. There will not be much variation. If there is not much variation, then we can simply take an arithmetic mean of the same. Okay? So the first method in this row, we call it arithmetical mean method. Arithmetical mean method. ठीक है? So this is the most simplistic method, that if you suppose you have n number of rain gauge stations, then I will take a simple mean of all those stations. So this mean rainfall represented by P bar will be given by 1 upon n, okay, let me represent by capital N, I equals to 1 to n, Pi. Right? This thing we have already calculated before when we were solving the numerical. Okay? So it's a simple averagized mean, or the arithmetic mean of all the rain gauge stations. Right? So just write a note under it. Write a note. If stations are uniformly distributed, over the area, and the rainfall rate also does not differ much, at various stations, this method gives satisfactory results. But if the topographical differences are many, and oblique or the rainfall rate vary considerably, this method can produce large errors. Right? So any of the two reasons, if they're not matching up, either the rainfall is very much variable in nature, or the topography of the area is quite variable. Right? In both the cases.
Excuse me, sir.
Yes.
Sir, can you repeat once?
What?
Sir, the note which you said right now.
Okay. If the topographic differences are many, and oblique or the rainfall rate vary considerably, this method can produce considerable or large errors. Alright, so any of the two reasons if vary, this method is not proper. So next we move on to second method. अब देखिए, इस मेथड में एक और खामी है. क्या खामी है? Suppose this is my catchment. There is one rain gauge station here, and all the other rain gauge stations are clustered over the next area. Right? Obviously, this rain gauge station is representative of much more area than the other ones. Right? But in this arithmetic mean method, we are giving a same weightage to all the stations for calculation of the mean rainfall. Isn't it? कैचमेंट चाहे रेन गॉज स्टेशन चाहे जितना ही एरिया कवर कर रहा हो कैचमेंट का, but I am giving a same weightage to it, right? Average वैसे का वैसे ही निकलता है. So now the other two methods in the list, what they have improved over this method, that they are giving a certain weighted average to each station. ठीक है, जिसके पास जितना ज्यादा एरिया, रिप्रेजेंटेटिव एरिया होगा जिस स्टेशन के पास, उसकी रेनफॉल को भी उतना ही ज्यादा वेटेज मिलेगा. Correct? But there is variation in both the other methods also. So next comes in the list is Thiessen's polygon method, very important method. Asked a number of times in UPSC examinations also, right? So what we do, suppose there are n stations in a catchment area, so we mark the station in a topographic map, ठीक है, and then we join all the stations by straight line, right? And in such a procedure you will find that a polygon is formed. ठीक है, सारे stations को आप join कर देंगे तो एक polygon form हो जाएगा. Now what we do, we further divide this polygon into some simplistic figure such that all the stations get some representative area. ठीक है, सारे stations को यहाँ पे join कर दिया हमने. अभी हम क्या करेंगे, suppose I may also join this thing. यहाँ पे एक quadrilateral बन गया. अभी क्या करें, suppose मुझे हर स्टेशन को separate out करना है. Maybe I'll join a center point of this figure. अब ये वाला जो स्टेशन है, स्टेशन नंबर 1, it got this area, so now it is representative of this area. This station number 2, it got this area. Number 3, it got this area. Number 4 here it got this area. सबका एरिया. अब यहाँ पे भी हो सकता है कोई स्टेशन हो नंबर 5, तो उसको क्या करेंगे, ये वाला एरिया दे देंगे. ठीक है, देयर इज नॉट अ फिक्स्ड रूल कि आप कैसे डिवाइड करते हैं, बट आपको अपना कंसाइंस यूज करना पड़ेगा. ठीक है, बहुत तरीके हैं इसको यूज करने के कि कैसे इस एरिया को डिवाइड किया जाए, वो डिपेंड करता है डिवाइड करने वाले के ऊपर. ठीक है, अब जैसे सपोज कीजिए मैं इसको दो ट्राइंगल्स में डिवाइड कर देता हूँ. जब भी आपको किसी क्वाड्रिलेटरल को डिवाइड करना हो ट्राइंगल्स में, व्हेनेवर यू वांट टू डिवाइड अ क्वाड्रिलेटरल टू ट्राइंगल्स, ऑलवेज ट्राई टू जॉइन द शॉर्टर ऑफ डायगोनल. जो भी ये रूल ऑफ थंब कह सकते हैं आप इसको, कि ऑलवेज जॉइन द शॉर्टर डायगोनल whenever you want to divide a quadrilateral into a triangle, right? Now see, there are 3 stations here, station number 1, 2, 3. Now if I want to give a particular area to each station, what I'll do, how can we divide the area into a inside a triangle? कैसे divide करें, anyone? Yes, अगर आपको ट्राइंगल को 3 एरियाज में डिवाइड करना है, व्हाट कैन वी डू? इट्स वेरी सिंपल. You can draw perpendicular bisectors, isn't it? So यहां से आपने perpendicular bisectors ड्रॉ किए. Obviously these all will meet at some point. ठीक है, now if you can see that the area is pretty much divided, like this will be the area for station number 1. ठीक है, this will be the area for station number 2, and the rest will go to station number 3, right? So we have pretty much divided the entire area into 3 parts. This is for this triangle. Now you can see the station number 3 and station number 2 also share some area from the neighboring figure. So you can further divide this figure also to give some area to station number 2 and 3 and all the other stations, say station number 4 and station number 5. ठीक है, इसको भी हम डिवाइड कर सकते हैं इन अ सेम और डिफरेंट मैनर. ठीक है, अगर मैं चाहूं तो यहां से एक कुछ सेंटर लाइन से ड्रॉ कर दूं. ठीक है, तो यहां से भी दिस एरिया विल गो टू स्टेशन नंबर 2, this area will go to station number 3. So now station number 3 have got this area also and this area also. Station number 2 had got this area also and this area also. Similarly, the station number 5 might get this area. या आप इसको और फर्दर डिवाइड करना चाहते हैं तो और फर्दर डिवाइड कर सकते हैं. अगर बीच में यहाँ पे कोई स्टेशन नहीं है तो इस फिगर को भी हम फर्दर डिवाइड कर सकते हैं. ठीक है, सो देयर आर n number of ways which we can divide the figure, but try to make a figure simplistic so that the things can be calculated. ठीक है, one of the important things in this method is suppose we have a catchment here and obviously there will be some rain gauge stations will be inside the catchment. Obviously some rain gauge stations would be outside the catchment. So we do consider these rain gauge stations also. तो हम जब join करते हैं line को, so we not only join the inside ones, we also join the outside ones. In that case, ठीक है, but the area which we consider is limited to the boundary of the catchment. ये जो area है ये catchment की boundary तक ही हम लेंगे. We will not go beyond that. ठीक है, समझ में आ रही है चीज? Anyone has any doubt up till here? So this is a good thing in this method, that if some rain gauge station is covering a larger area, it will also get some larger value of weightage, right? And we are also considering the rain gauge stations which are just outside the catchment boundary, not only the ones which are inside. Correct? So that was the thing. Later on, what you can do, you can find out the weighted average. How to find out the weighted average? Now this P bar will be given by, suppose we have considered the first station P1, the area covered by it A1 plus P2 A2 plus P3 A3 up to Pn An divided by entire area A of the catchment. Right? I can also write it like summation of Pi Ai upon A, where A is the entire area here, I equals to 1 to n. Right? So you got how to find out the values according to this method. ठीक है, तो जो मैंने बताया वो चीजें आपने शॉर्ट में नोट कर ली होंगी. दैट वी हैव टू डिवाइड द एंटायर एरियाज बाय जॉइनिंग all the stations through straight lines and thus forming a polygon like this, and then we are further dividing the polygon into simplistic figures, maybe a triangle or a quadrilateral, so that we can evaluate the area. Whenever you have to divide a quadrilateral to a triangle, the shorter diagonal is to be joined. These are some of the things which you should keep in mind. ठीक है, बाकी एरिया डिवाइड करने का कोई हार्ड एंड फास्ट रूल नहीं है. That depends on the conscience of the observer. So shall I move to the next method if this is quite clear to you? चलें आगे?
Yes, sir.
Okay. So next we'll go to Isohyetal method, which is the third method in the list. Isohyetal method. So Isohyetal method also works on this weighted average thing. तो जो formula use होता है Isohyetal method में, it's pretty the same, but the concept of dividing the area is different. How it is different? See, यहाँ पे जब आप एरिया कैलकुलेट करते हैं, यहाँ पे भी हमें टोपोग्राफिक मैप चाहिए होता है जिसके ऊपर ये सारी लाइंस ड्रॉ होती हैं, ये पॉलीगन फॉर्म होता है. दिस इज ऑल हैपनिंग इनसाइड अ मैप. एंड हाउ टू मेजर द एरिया व्हेन यू आर यूजिंग अ मैप? I told a tool in the last class. How to find the area of a map or area of a some particular area on a topographic map. There is a particular instrument to find out that. Anyone? Anyone?
Planimeter.
Planimeter, right? Where are the other guys? Utkarsh Singh?
Yes, sir.
Sir, you should also come and speak in the class now, or always only one person is answering.
Sure, sir.
Oh, okay. So I'll move forward. Isohyetal method. So now, isohyetal, right? There are two terms in this, iso and hyetal. ठीक है? So hyetal refers to the rainfall. जो height term होता है वो rainfall को represent करता है. And iso represents for? iso किस लिए यूज होता है? isobar, isotherm. किस लिए टर्म यूज होता है iso का? For something which is same in nature, right? Isobar, the points having same pressure. Isotherm, the points having same temperature. There are various things. Similarly, here we have isohyetal, that is points having the same rainfall. आपने कभी कंटूर के बारे में सुना? Have anyone heard about contour?
Yes, sir.
Right? Contours क्या होते हैं? They are the points, or that is a curve that join the points of same reduced level, right? And we join to form a contour. There could be a contour of 100 meter, there could be a contour of 80 meter, and so. Similarly, we mark the contours for rainfall, which we call isoheight. ठीक है? अब ये contours बनाते कैसे? So it actually requires very much a skilled mind to draw these contours. ठीक है? अब सपोज कीजिए यहाँ पे बहुत सारे रेन गॉड स्टेशंस हैं. Obviously, in this method also we'll take the help of the rain gauge stations which are actually lying outside. ठीक है? Suppose कीजिए here we have some 7 centimeter of a rainfall. Here we have some 7.2 centimeter of a rainfall. Here we could have like 7.6 or 7.5 centimeter of a rainfall. So ये सारी rainfall की values की help से हम क्या करेंगे? We can draw contours which pass from the average values of this rainfall. So we could have a contour of 7 going through here. We could have a contour of 7.1 going through here. Then we could have, if I want to draw a contour of say 7.3, it will pass out somewhere here like this. तो यहाँ पे बहुत ही स्किल चाहिए होता है कि आप कंटूर्स को कैसे वेरी कराते हैं एक टोपोग्राफिक मैप में. ठीक है? एवरीथिंग इज ड्रॉन हियर इन अ टोपोग्राफिक मैप. And obviously we'll also take the help of planimeter to find out the area, right? So in that way I could go for a contour of say 7.8. say here the rainfall is 8, here 8.3, here it could be 8.2. so if I have to draw a contour of 8.1, I can pretty much draw it like this, right? Similarly I can go for further other contours. तो सारे ही रेन गॉज स्टेशंस की हेल्प ली जाती है जो कि इनसाइड द बाउंड्री है कैचमेंट के और आउटसाइड द बाउंड्री है कैचमेंट के. ठीक है? सो Once this contouring is done, now what we do, अब ये प्लानीमीटर को हम क्या करेंगे, एक पॉइंट पे सेट कर देंगे. दिस इज द स्टार्टिंग पॉइंट ऑफ द एरिया ऑफ दिस कैचमेंट. ठीक है, इसको आप 0 मान लीजिए. नाउ व्हाट द प्लानीमीटर डज, इट एक्चुअली रिकॉर्ड्स द एरिया रिलेटिव टू दिस पॉइंट. ठीक है, अब सपोज मुझे इस कंटूर तक देखना है कि कितना एरिया आ गया, दिस पर्टिकुलर कंटूर, राइट. सो द प्लानीमीटर विल रिकॉर्ड द एरिया फ्रॉम हियर टू हियर. ठीक है, सपोज it is a dash. Now suppose I want to have the rainfall to the next contour like this one, right? So planimeter will record the area from here to here, let's say a double dash. Okay, so in this way I'll mark all the areas with the help of the planimeter to each and every contour that is formed in the area. There might be sub contour here also. ठीक है, but we are curtailing up to the boundary of the catchment. जो भी boundary of the catchment होगी उस पे last contour mark कर लेंगे हम, वहीं तक ही अपने एरिया को confine रखेंगे. Okay, the boundary of the catchment will be having the last contour. So now what we do, we just derive the area between two successive contours. Like I may take this first area. Now this will entirely belong to this contour because there is no other contour here, right? When I'll move to the next two contours like this one and this one, then I'll find the area that is confined between these two contours. So how will I find? I know the area up to a dash. I can also calculate area up to here. Let's say a1, right? So area between this first contour and second contour will be how much? A dash minus a1. We can easily find out that that area by subtraction, right? Similarly, I can find out the contour area that is confined between these two contours. Similarly, the other ones. Now, how to give? Now, if I have to use this formula, certainly I need two values. One for the rainfall, another for the area that is confined. ठीक है, तो अभी देखिए हमने क्या किया यहाँ पे. The area that we have taken is between two contours. So it is between two rainfall values, right? Like this is 8.1 contour, this is 7.8 contour, right? Area मैंने इसके बीच का लिया. Suppose मुझे ये कोई एरिया मिला, suppose this is A3 area. अब मैं इसकी rainfall value क्या रखूंगा? So the rainfall value that I'll keep will be actually an average of this contour and this contour. ठीक है, because the rainfall here is varying from 8.1 to 7.8. So I'll give an average value of rainfall to this particular area A3, that will be 8.1 plus 7.8 by 2. 7.95. Okay, so this will be my P3. ठीक है, तो अभी मैं आपको समराइज करके बताता हूँ. देखिए पहला एरिया ये हो जाएगा A1. I can pretty much use this contour of 8.3. ठीक है, so now this will be my P1 value. Now the next area will be between this contour number 1 and contour number 2, this area, right? Shall I change the color? It will be this area. Now this next area will be an average of this 8.3 and 8.1, so 8.2. So this will be my P2 value. Okay? In this way, you will have to successively find the area. A1, P1, A2, P2, and A3, P3. Okay? Where this A will be the area between two contours, two successive contours, and P will be the average value of the two contours जो भी आपने choose किए हुए हैं. ठीक है, so in this way we can move on. Understood the method? Rest you have to apply the same weighted average. The same formula you will have to apply. ठीक है, अब यहाँ पे एक catch है. What is the catch here? Whenever you will be given a numerical to solve, it is not mentioned that the area is incremental in nature or it is a entire area taken from the planimeter. ठीक है, तो आप ये देख के समझ सकते हैं. जैसे अगर आपको वैल्यूज ऐसे दी होंगी कि दिस इज द कंटूर, दिस इज द एरिया. ठीक है, अब कंटूर नंबर ये कोई 1 कंटूर है, सपोज कीजिए ये 100 सेंटीमीटर का कंटूर है, ये 90 सेंटीमीटर का कंटूर है. ठीक है, ये मैं अभी बढ़ते फॉर्म में लगा देता हूँ, दैट विल बी गुड अंडरस्टैंडिंग. सपोज इट इज 110 centimeter, it is 120 centimeter, it is 130 centimeter, and if the area values you are getting like say 1500 square kilometers, 1800 square kilometers, 2900 square kilometers, 3200 square kilometers, right? So if all these area values are increasing order, then you can simply understand that the area is considered taking some point of reference, right? So it is same planimeter area which is taken from this point of reference, and it is always in the increasing order. Okay, so the incremental area you will have to find out. Now the values are given like this, all in the complete area up to that particular contour. So what you do, just find out the incremental area. Like 1500 will remain 1500, then difference of these two 300. Okay, this will be the incremental area, and what will be the average rainfall? pi क्या होगा यहाँ पे, जो इन दोनों की average rainfall होगी. Like the first contour we will take as it is 100, the next contour will take an average of 100 and 110, that is 105. Then next, the area between these two, how much? 1100 square kilometers, and then the average of these two rainfalls, these two contours, that is 115. Then the average of these two, that is 300, and the average of these two, that is 125. Okay, so difference of these, average of this. In this way we get both the areas and the average rainfall. Anyone has got any doubt up till here? Yes, no?
No, sir.
ओके, ठीक है, तो आपके पास अभी ये AI वैल्यूज भी आ गई और PI वैल्यूज भी आ गई. Just are simply A1 P1 plus A2 P2 plus A3 P3 up to AN PN divided by the entire area. ठीक है, कैन यू सॉल्व द प्रॉब्लम? बट आपको ये जरूर जज करना है कि एरिया इंक्रीमेंटल दिया हुआ है या एरिया होल फॉर्म में दिया हुआ है. आपको एरिया इस फॉर्म में भी दिया जा सकता है, आपको एरिया इस फॉर्म में भी दिया जा सकता है. बोथ द ऑप्शंस आर अवेलेबल, यू हैव टू यूज योर कंसाइंस. Correct? So please just solve a few numericals from the book by yourself. And up to here will be the syllabus for your T1 exam.